Hello everyone and welcome to another stream. So today we're going to continue with Vulkan and Rust, and we're just starting, so we managed last time to create a Vulkan instance, so we are going to continue from there today. You can find the source for this project in my GitHub. The project name is Icarus and you can find it here. I'll send the link on the chat in case you're interested. So let's see where we are in terms of source. Last time we created the instance. And if I run the program, we were printing the number of extensions and the result of pk create instance. So what's next on the Vulkan tutorial? So here we were creating the instance, and the next step is to check for extension support. But before that, I'm going to implement the cleanup because it's easier, I think. So I'm gonna put it here. In order to destroy the instance, we just need to call this pk destroy instance, passing the instance that we got and a null pointer. But of course, we need to create the bindings for the pk destroy instance, which we are doing manually right now. So if we go to the pk module, we can add a new method from the list of in this extern block, and we need pk destroy instance, which takes the instance. Actually, let's look at the Vulkan reference. What is the signature for this function? So we take the instance and the allocator, which we are not using so far. And we don't return anything, so like this is fine. So does it run now? Yeah. Now it works. Great. So what's the next step? Checking for extension support. If you look at the pk create instance documentation, then you'll see that one of the possible error codes is pk error extension not present. We could simply specify the extensions we require and terminate if that error code comes back. That makes sense for essential extensions like the Windows system interface, but what if we want to check for optional functionality? So we can use pk enumerate instance extension properties to enumerate extensions. Alright, so I'm gonna add this method here. And take a look in the specification as well. So it takes a pointer to a layer name, then the second parameter is the property count as an output pointer, and then we also return the actual properties. BK extension properties, and the function returns a result. So I don't think we have defined the BK extension properties, so probably we'll need to define it. Actually, we already have this method declared up here. So yeah, because we were already enumerating extensions even before creating the Vulkan instance, right? So first we get, the way this function works is first we pass in this u32 to get the count of extensions that we have, and we pass in null for the extensions field, and then we can actually allocate maybe a vector for the actual extensions. And we can have it, I don't know, BK extension properties. So we could maybe initialize this as the default status, and then initialize as many as we got from the extension count. But in order for that to work, we would need to derive the default rate, right? So we can implement it. Actually, can we derive the default rate? Like so. Does this work? It doesn't, because yeah, an array does not implement the default rate. So we need to implement the default rate manually, basically. But it's no big deal. We just return self, extension name. We can initialize everything as 0. And the spec version also as 0. And now we should be able to call the default. Okay. So if we go back to our main, we have initialized the extensions, and now we can again call the enumeration function, but this time we're going to provide storage for the extensions. So we get the extension count, and can we also pass the extensions like this? I don't really know. Expected use size found 32. Okay, so first we need to cast this as use size in order to initialize a vector. What else? The trait clone is not implemented. Okay, but we can derive it. So, what other errors were we getting? Expected struct decay extension properties, but found back. Yeah. So we cannot pass in a mutable reference to the vector. We need actually a raw pointer. You see the documentation for back, if we have any method that to get the data mutably. We have this as mute pointer. Would this work for us? Let's give it a try. So instead of doing can we do this? It seems like we can, right? So, and now maybe we can print the extensions somehow. Maybe we can do for extension in extensions. And then we can print the extension. And we're going to need to derive the debug rate. Oops. Clone debug. Let's see. Let's try to run this. Whoa! And we are printing the extension properties, but yeah, since these are arrays of I8, then they are displayed in this way, which is not very helpful. Oops. So how can we? Maybe we can just, if we get the extension, we can print the, what was the actual type? Extension name. Can we, this is a vector of I8. Maybe we can create a C string from the vector, because it should be 0 terminated, I think. Properties, PK extension properties. And null terminated, yeah, it is guaranteed that this is going to be null terminated, so I think we can just use a C-string. And how do we construct one of these? We are certain. The C-string new method will actually check that the provided U8 does not have 0 bytes in the middle and returns an error if it finds one. From back. What about this? So this one checks that let me Google this. What else do we have from back with null unchecked? Do we have a way to get only the non-zero? Maybe we can do, it's going to be unsafe, but maybe we can do as pointer, and then we can actually construct the C-string from the pointer. From row. Let's see if that works. Okay, we need to import C-string. And extension name is private, but we're gonna make it non-private in a second. So first we import string, and we're gonna make both of these public, and then try to run it. I did a mistake. Types differ in mutability. So from raw takes immutable. Okay, so we can use the other one, the asmute pointer. Okay, warning. Cannot borrow extension name as mutable as it's behind 100% reference. Okay. You like it like this. Cargo run. It worked for the first two, but then we are starting to get right because we are trying to free the string. So do we have actually a sister, right? How can we construct one of these? From pointer. And this one takes a mutable pointer. Yeah. Need to get used to Vim. No function or associated item name from raw. Is there from raw? Weird. Ah, from pointer. And now we get our extensions. 1, 2, 3, 4, 5, 6, 7. Yeah, I think we got 19 of them. There's one for xlib, which we are using to create the window, so I'm guessing we are going to need to specify some of these extensions later on. But let's continue with the tutorial. So you can add this code to create. Get required instance extensions. So where is it using this? Yeah. So far we were specifying zero extensions, but maybe we are gonna need to get some extensions. I'm not sure if we need to specify some extensions or what. Let's read a little bit the documentation, the reference. Sorry, I need to take a quick break. Be back in a minute. Okay, I'm back. So we were checking if we need to specify any extension when we create the instance. So let's read a little bit the documentation. So create instance verifies that the requested layer exists. If not, it will return an error. And then it checks the requested extension. If a requested extension is only supported by a layer, both the layer and the extension need to be specified at bk create instance time. So enable layers. valid usage. Flags must be 0, style must be... So if I go to the definition of the actual struct, maybe there will be more information. Okay, so we don't know if we need any extension or not. Let me see if I have... do I have... glf w installed? I'm not sure. I don't think I have glf installed. I just want to check the source code for this thing. See what extensions it specifies. I'll close this. Does it hardcode the extensions that it needs? Oh, it's super slow when I'm streaming. Should be line 230 or something. So it's calling this function which enumerates here. It's doing different things depending on the operating system. Then it enumerates the extensions. It allocates an array. So it looks for KHR surface, xlib, and xcv. So I think we're going to, for now, hardcode this extension and this one, since we are on Linux. So now, instead of specifying 0 extensions. We're gonna change it to 2 extensions. And then here we're gonna have an array. And we're gonna specify these 2 extensions. We need to null terminate them because they are C strings, and also cast them to a const pointer of i8, and oops, the same thing for the xlib surface. So let's see if we're still running. Okay. Expected pointer find array of 2 elements. Okay. Maybe if we set it as a pointer. Yeah, that works. And we are still getting success. So, okay. What's next? For layers, we are still specifying 0. We will talk more about this in the next chapter. So, I think we completed this first chapter. Maybe we can start with the next one. Validation layers. The Vulkan API is designed around the idea of minimal driver overhead, and one of the manifestations of that goal is that there is very limited error checking in the API by default. Okay. Vulkan introduces an elegant system for this known as validation layers. Validation layers are optional components that hook into Vulkan function calls to apply additional operations. Common operations in validation layers are checking values of parameters against the specification, tracking creation and destruction to find leaks, checking thread safety, and logging all the calls and its parameters. Okay. So here's an example of what an implementation function that does some diagnostics might do. Here it checks that createInfo is not null pointer, and also that the instance is not a null pointer. Okay, so we don't have to do this ourselves manually. We can somehow use layers to do it for us, I guess. And then we can enable or disable them. Vulkan does not come with any validation built in, but the Linergy Vulkan SDK provides a nice set of layers. They are completely open source. Okay. There were formerly 2 different types of validation layers in Vulkan: instance and device specific. Device-specific layers have now been deprecated, which means that instance validation applies to all Vulkan calls. Okay, how do we use validations? Okay, so we can specify this validation layer name. and then we check. Okay, so let's start by trying to enumerate the layers. Same thing that we do with the extensions. So it's gonna look pretty similar, I think. Passing a layer count, a new pointer first, and then we can create a vector of decay layer properties. I'm just typing something very similar as we have here. And then we call again the same function, but now... Hello Elias, welcome to the stream. How are you doing? I don't know if you spoke a long time ago, I'm not checking chat very often. So we are going through the Vulkan tutorial. This is explained in C++, but I'm trying to port it to Rust. So yeah, I'm not so experienced with Rust, and I have never programmed in Vulkan, so it's a bit hard for me, but I'm trying to learn how it works. Fine, okay, nice. So we are trying to enumerate the instance layers that are available on our system right now. So we can pass in the layers as smooth pointer. And we're going to need to add this function into our bindings. If we do cargo check now, we get a ton of errors. Basically, we need to declare all of these types and these functions. So let's do that. We can go here and add a new function. Decay, enumerate, let's see the actual function signature in the specification to see the types of the parameters. It takes a pointer to the property count, which is a U32 pointer, and then p properties, mute decay layer properties, and it returns a decay result. So we need to define also this type, decay layer properties. We can put it after the extension properties. Gonna copy this, and then we need to convert this to Rust. Okay, so layer name is gonna be an array of I8 with max extension name size, spec version is gonna be IU32, and implementation version it's also IU32, and finally description is another array with bk max description size. This one is a different constant, but it's also 256 apparently. So we can put it here after the other one. So let's see, oops, let's see where we are at. Have a check. No function or associated item name default for bigger layer properties. And clone is not satisfied. That's right. So the same that we did for the extension properties, we need to derive clone and debug. And also, because we are initializing an array, well, a vector of extensions and layers, we need to implement the default trait as well. So derive clone and debug, and we implement the default trait. Let me grab this. Paste it here and change the bk layer properties. Now we just need to change with the proper fields. Layer name, spec version is the same, implementation version can be set to 0, and description, we basically initialize everything to 0 as the default. And remove these extra spaces. Okay, so it compiles. So let's also print out the layers the same way we do it for the extension. Layer, in layers, and then we can print layer, layer name, and we can also print the description. Oops. hope I didn't make any mistake. You are training an artificial intelligence, really? No. What is the project about? Are you using Python for your AI? I think it's used very often, right? You want to make it play a small game. Oh, very nice. Do you want to share a link to your project or whatever? Feel free to send it here in chat and I can check it out. Okay, I think we are printing the layers now. But it would be nice to add a new line in between so we can distinguish. But yeah, we have these 6 extensions: NVIDIA Optimus and something from LunarG, and we also got the Chronos validation. You're playing a cheated version of a game to gather data. Not sure if it will work. So you made the game and then you're trying to cheat at your own game? That's funny. Okay, let me add, maybe put here streamline extensions, and then we can put here layers. What language are you using to create the AI? So now it looks a little bit better. You can see 19 extensions and 6 layers. I will add here the number of extensions that we got. Extension count, we can remove then this print line, and then I'm gonna add a new line here and the number of layers as well. You use Java. You made a game like Flappy Bird. The cheated version works a bit like Superhot. What do you mean super hot? Like it goes faster than the usual gameplay? But it's nice that you coded Flappy Bird in Java. I have programmed a little bit in Java, but I'm no expert. I'm not sure if I would be able to program Flappy Bird in Java. So I think now it looks much better. 19 extensions and 6 layers. I think we can move on now. So we know that we have this Chronos validation layer. We can enable it hard-coded when we create the instance. So we can specify that we have one layer and then pass in an array. And specify the Chronos validation that we want. Let's make sure it works. And we're getting this warning now, which maybe means that the validation kicks in. Performance support is disabled, consider sysctl. Can I run this as a command or something? Sudo. You can choose to not jump or jump every frame before it goes to the next frame. Cool. So like you can single step each frame and then decide what to do. So you can basically win always, right? If I cargo run now, do I get... Yeah, now I don't get the warning. Nice. So let's see what's next. You got inspired by this video. Let's see.
For hundreds of years, analog computers were the most powerful computers on Earth, predicting eclipses, tides, and guiding anti-aircraft
Okay,
guns.
it's pretty long.
Then, with the advent of solid-state transistors, digital computers took off.
But maybe
now virtually every
save it
computer
and
we
take a look
use
later.
is digital. The digital computer, if you want to add 2 8 error. So when you think of analog computers, you can think powerful, fast, and energy efficient, but also
Does it explain the
non-repeatable
artificial
and
intelligence
inexact.
here?
And if those sound like deal breakers, it's because they probably are. I think these are the major reasons why analog computers fell out of favor as soon as digital computers became viable.
I will save it and
Now,
maybe
here's why
take a
analog
look
computers may be making a comeback. It also
I'm gonna to create a new file to maybe I will take a look later. Thanks for the link, by the way. Looks pretty interesting. I never got to play with artificial intelligence, so to me it's something new. Okay, where were we? It explains how the first neural network could decide if something was a square or a circle. Oh. I remember back when I was in college and we did a little bit of artificial intelligence. What we did was train a model to recognize numbers, like written numbers in an image or written. And the goal was to create a program that was able to identify which number it was. It was pretty interesting, but I almost don't remember anything at all. Okay. So here we first check if the validation layer is available, and we return false or true depending on whether we find it in the list of layers or not. Okay, but I already checked manually. Maybe for now I will hardcode the validation layer always enabled. Yeah, so here they enable it depending on if it's enabled or if it's available or not. Okay. your game is only 32 by 16 pixels. Oh, that's pretty small. 32 by 16. That's like pretty small. And the graphics, are you using sprites from somewhere or did you create them yourself? You are using processing for graphics and input. You mean that you draw squares or something like that? Or anyway, let's continue with this. The message callback. Validation layers will print the bug message to the standard output by default, but we can also handle them ourselves by providing an explicit callback in our program. This will also allow you to decide which kind of messages you would like to see, because not all are necessary fatal errors. So yeah, here they want us to set up this message callback, so instead of printing errors to standard out, we can control what to do, right? Processing.org is a web. Let me see. Wow, I cannot read anything. No. So you can get input that resembles these kind of things. It's a software sketchbook and language for learning how to code within the context of the visual arts. So this is the library or framework that you use to create this game. Well, the artificial intelligence. The game is in Java. I've never heard of this. Okay. No, you are making the AI. And you use that for rendering the keyboard and mouse input. Okay. Looks pretty complete actually. I'm not going to understand it now, I think. Okay. Sounds interesting, definitely. Okay, so we are trying to create this message callback. And it's using this BK extension debug utils name. So I'm gonna try to find this on the Vulkan include files. It's this string. So they are enabling this, and it's a layer. So they are using this layer called, fuck, I didn't paste it correctly. So maybe it's in the reference as well. Hold on a second, I'll be back in 2 minutes. I'm back. So we were looking for this debug extension's name. Which is actually called like this. So do we actually have this extension, this layer? We have Chronos validation, Chrono debug utils. Yes, we have it as part of the extensions. Okay, so how do we use it? We set it in no, it's an extension, right? So we can put it here and then enable it here. Let's try to run this. Still running fine. And then we create a static callback that's going to be called when we want a debug message. And how do we specify the debug callback later on? We use this create debug utils I'm not following. here it's explaining the parameters of the debug callback. The callback returns a boolean, and all that remains is telling Vulkan about the callback function. Perhaps surprisingly, even the debug callback is managed with a handle that needs to be explicitly created and destroyed. Such a callback is part of a debug messenger, and you can have as many of them as you want. Add a class member for this handle right under instance. So we need a variable of this type, debug messenger. And do we do this before or after creating the instance? After. So after creating the instance, we can have this debug messenger, which I'm going to set it as null pointer for now. Not sure if that's the proper type. Then we create this setup debug messenger that we call after create instance. We need to fill up this bk debug utils. We need s-type, this one, the message severity, we specify a bit flags that we want message verbose, warnings and errors. Then we also have the message type, which is also bit flag, general, validation. I'm gonna copy paste for now and then try to make it work. And then we also pass the actual callback that we still haven't defined, and user data. Let me see if I can find this in the specification. Yes, I'm gonna grab this and go to bk and add this we got pnext, which is a constant void pointer. Then we got flags, then we got message severity, then we got message type, and we got the user callback and the user data. It doesn't want to format for me. We're gonna need to declare all of this next. But how do we set the callback? This struct should be passed to the bk create debug utils messenger function to create. Unfortunately, because this function is an extension, it's not automatically loaded. We have to look it up its address ourselves using bk get instance proc address. Right, so we need to load this function. And we're gonna need bk get instance proc address for it. So let me search for this function. And then add it to the list of functions. So it takes the instance and the name of the function that we want to load. And it returns a pointer, a function pointer, basically. Which we need to specify. Gonna look for this type. So this basically is a function pointer of a function that doesn't take any argument. Right. So let's add this type. Flags, instance create flags. Needs to be a function callable from C, so I think it needs to be external C fn that takes nothing. Is this a proper type? Maybe. let's add the other types as well. This BK debug utilities, messenger create flags, type, and message severity, all of them are BK flags. So I'm gonna add them down here. Message type, message severity flags, and message create flags. And we are missing the actual callback type. So it's a function pointer that takes the severity, the type of message, callback data and user data, and returns a bool 32. Okay. So we can add it here. We take this, this, then this, interval void, and we return it's not formatting for me. Do we need to specify the names? Maybe we do. Let's see how many errors we have. So we're missing colon on line 117. What else? cannot find type bk debug details results, which we are using on line 45. So this is an enumeration. Is it? So the structure takes flags. So here it's using flag bits, but then on the structure, is using create flags without bits, and the same for the severity and the message type. Could it be wrong or something? This one doesn't have the bits part. What were the compiler errors? BK Debug not found in this code. Okay, BK bool. this is just defined as a U32. And now it cannot find BK debug utils messenger callback data. Where are we using this? Right, we are missing this part. Which is this struct with a bunch of things. Where do I put it? Here. We get a bunch of data every time. Message. Q label count. There are quite a few objects involved in this creation of the debug messenger callback. And I forgot all these types need to be recursive. Okay, debug utils message create flags. So we have the messenger create flags. Also, do we have a message create flags or no? So this should be actually messenger. Okay, finally it is compiling. Let's go back to our main. So the first thing we need to do is actually load the function. Let me put it here. So we call get instance proc address and we pass in the name of this function, which is an extension that we want to see if we get back. So let's try to run this part and see what we get if we try to print. Let's see if we can manage to print this pointer that we should get back. Okay. Also need to comment out this. We're getting back a 0, which is not good. Why are we getting back a 0? dk create debug utils messenger extension, and I missed, as always, needs to be a null terminated string. Now we are getting an actual value, and now we need to cast it into this type. And I don't know how to do this in Rust. Maybe we need to use transmute. Which is unsafe, but I'm not sure if there is a better way. So the first type I think can be inferred, and then the second type should be this PFN. Right? So basically I'm trying to cast between this type and this type. Both are function types, function pointer types. So will it work? Cannot find type, PK, create, debug, utils, messenger extension. Sorry, not that type. This time. And its signature. I will have to look up. It takes the Vulkan instance. It also takes a pcreate info. Takes an allocator. And it returns the messenger. And also returns a BK result. BK debug utils messenger. So we don't have this declared. I thought we declared it. And this is just a handle, BK non-dispatchable handle. So basically the same that we did with the instance. And it seems to be compiling. So now that we have loaded our functions, we should be able to call it, passing the instance, the create info, which we have here. Then for the allocator we can pass in null, and then we get the Debug messenger. Let's see if we actually got something back, because that was a lot of stuff. What was the name? Debug messenger. Ah, I need to comment it out. Still getting some errors. Okay, now it's complaining about all the flags that we don't have on the enumeration types. So let's go one by one. So that was one error. And all of these should be public. This should be public. Then if we go to main, result, we should print it as debug. Missing flags and p next in line 88. So for p next we can just set it as null and flags just empty. And I'm going to, for now, set these flags to 0. See if we can get it compiling at least. These are actually on their own lines. Okay, back to one error. Now we just need to define the debug callback. And after this, I'm going to leave it for today, because I have to go. So let's put it on the bottom. I think this one is the one where we didn't need the bits. Message type. We also get the callback data. and the user data. And we should return bkable32. Let's just return 0 and print something. We're not importing cvoid here. So let's import it. And I missed an S. Finally, we get many warnings, but it seems to be compiling. Let's try to run it. And we get some problems. Message severity must not be 0. So yeah, but we are getting actually some debug information. Basically, we cannot pass 0 as the message severity and the message type, which we did to spend less time, but yeah, here. Basically, this is the part that is missing. We need to fix this, but I think that other than that, we're good. So I think I will close it for today. Thank you for joining in, Elias. I don't know if you're still there, but I'm going to stream next time, maybe tomorrow. Yeah, so if you are interested, I think tomorrow, more or less the same time, I will be here. So, see you later.